topic what we are supposed to cover, and this is the last topic in your DNS, a very short topic known as how the header of the DNS would look like, and what are all the elements involved in the header. So basically, this DNS has only two type of message, as you know, because it is a client server model. So we have either a query or a response. Fine. And one more peculiar point what we have to remember here is both types have the same format, right? So the query message, so if I go with the query message, so only two type of message I have. One is a query as well as a response. You know who is going with the query and who is going with the response, right? So if I go with the query and the response, so this query consists of only the header and the question section. So this is an how your message of a query look like, and this is how a message of a response would look like. So response has more what do I say, subsections when compared to the query, right? So the query has just an header as well as question, whereas the response has an header section, a question section, an answer section. Response section has an header, a question section, answer section, authoritative section, and additional section. So let me go into the first particular message, that is the query message. So both, either it is a query or it is a response message, we have the same header format. And remember, the header is of 12 bytes, right? They can ask you. So the header length is of 12 bytes. Either it is a query, either it is a response. It is of 12 bytes, right? Now, in the header section, if I go in depth with the header format, we have something called as an identification field, a flag field, the number of question records, the number of answer records, the number of authoritative records, and the number of additional records, right? So what basically this identification field does? So now you know that we are putting a query. For that, we are getting a response. Now, for example, to get identified by a host name to an IP address, what will the DNS client do? The DNS client will put a query to the DNS server. So I need an identification which indicates that basically it is a subfield used by the client to match the response with the query. Right now, I put a query. Let me call that number to be 1. So this identification field is identifying you the response with the query. Similarly, the next field, whatever we have, is the flag field. So this flag subfield once again is nothing but it is defining the type of the message what we are referring with respect to. What are the messages we have? Either it is a query or the response. So this flag field is identifying that whether it is a query message or whether it is a response message. Next, I have the number of question records. So this question records is only based on the queries. Right. Query is the one which is asking the question. So only in the question section we have. So the number of question records contains the number of queries. That's it. Right. Similarly, the number of answer records. Very simple. Answer records is nothing but once again a subfield used in what? Used in the response section. Remember, in the response section, both we have the question section as well as answer section. By this time, you know what does the question section do? The answer section holds the answer for the requested query, or basically it is a subfield which records the whatever the answer given by this particular query, and all zeros it will be set if it is a query message. Very simple. Since it is a query message is not giving the response here, so the query message will be set to all zeros. Next, I have number of authoritative records. So by this time you remember what are authoritative records. So it is nothing but an high-level service in the DNS hierarchy. Yesterday I told you there are 3 servers. One is the DNS resolver, one is the DNS root server, and one more is the authoritative name server. So this authoritative name server is nothing but a high-level server in the DNS hierarchy. And you know that what it holds. It holds the up-to-date information of the host name. For example, the host name is www.yahoo.com. So it will hold the IP address of that. For example, 192. 32.3.1 would be an IP address for that particular host name, right? So we have an authoritative server. So we need to also have the number of authoritative records to be maintained. So what does this do? It is once again a subfield and contains the number of authoritative records in the authoritative section. Okay, so in the authoritative section, it contains all these. So where can I have this? I can have this only in the response. Once again, the response holds more number of fields rather than your queries. So your authoritative record also falls in the response. Similarly, I have the number of additional records. So if required for any response, hello, yeah, if required, please mute. Shall I mute it? Hello, please mute all your coming call. Hello, are you able to hear?
Yes, ma'am.
Okay, fine. I have an additional records. So here, the additional records just contains the additional information for any response messages. Similarly, these would be your header format, and the two types of records what we have is a question record as well as a resource record. We'll not go in depth of all these things. So the DNS maintain two types of records. One is the question records used for question section of the query as well as the response, and the resource records are used in the answer, authoritative and additional information section of the response. So the DNS maintains two records. One is the question as well as one is the resource. Resources mainly maintained at the response, and something about your question records is mainly maintained at the question section. So this was the last topic what I was supposed to discuss in the DNS. So I'll just make a quick review. What is that we have studied? So basically I started with what does a domain name system refers to, and why we need this. So anything mapping from a host name to a what do I call an IP address, we go with respect to a domain name system. So we know by this time what is the need of a domain name system, and how many types of the namespace we can have, that is a flat as well as a hierarchical. Then I moved on to what is a DNS, and what type of namespace we are placing in a DNS. It is basically an hierarchical namespace, and we know that it is an inverted tree structure with the root at the top. And by this time there are 128 levels. That is 0 with the minimum, and the last is 127. And we have label. Some parameters are the labels, the root label as well as the domain name. Labels are nothing but your normal names what we give. The root name is nothing but an empty string or a null string, and the domains are nothing but the name given for each particular what do I say entries, right? So then we move on to something called as types of the domain name. So we have fully qualified domain name as well as partially qualified domain name. By this time you know what are these two. Then we moved on to something called as domains, and you know that domains are based on a subtree category in which the name of the domain is at the top of the subtree. So from then I moved on to how the DNS would look like in an internet. It is divided into three different categories. One is the generic domain, country domain, and the inverse domain. So generic specific to one particular what do I say, the application, or specific to whatever we are specifying with respect to. And country is of two length character, and inverse domain anything if we want a mapping between an IP address to a host name, then we go with the inverse domain. Then I moved on with the types of the servers. I think the types of the server I moved on with. We have something called as a DNS resolver, DNS root server, and non-recursive server. So then I moved on with the two types of queries what we can give. One is the recursive query, and one more is the iterative query. Probably our internet is based on the iterative response, and you know that our DNS works with UDP connection rather than TCP connection, because we don't want much overheads in case of the UDP. As well as the timely delivery we should go with. So it operates at port 53 with UDP as the lower level protocol. Right. So with this idea, let me go with some questionnaire section related to your routing protocol as well as what is that we have DNS. So I think the two topics whatever I covered recently is one is your DNS as well as one is your routing protocol. So all of you please be alert. I'll go with some MCQs related with the RP as well as the DNS. Right. So you have to answer to me now. Okay, read the first question. The domain which is used to map an address to a name is called as dash.
Domain.
Which is used to map an address to a name is called as
Inverse domain.
yeah, it is the inverse domain. Shall I proceed like this? Is
Yes,
it visible, all of you? Yeah. So it is the inverse domain, and anything mapping between a what do I say? An address to a name is an inverse. Anything mapping from a host name to an address is nothing but your the normal what do I
Domain.
say? Domain. Fine. So next one I'll go. Yeah. The term that defines registered host according to their generic behavior is called as dash. Yes. Registered host according to their generic behavior is called as dash. Just now I specified the entire DNS is classified into a generic domain, a country domain, and as well as an inverse domain. So anything specific to your specific to one behavior is referred to as what? I'm not
Generic.
able to. Yes, it is the
Generic
generic
domain.
domain. Yeah, whoever is answering, yeah, it's correct. It is the generic domain. Is it okay?
Yes, ma'am.
Yeah. Let us move on to the third one. Please read the question properly. The DNS client adds the suffix atc.jhda.edu. Before passing the address to dash. Whether it is to a client, whether it is to a server, or whether it is to a label or a recipient.
Server, ma'am.
Is it correct?
I'm
Others,
not.
please. Others, please respond. Yeah, the answer is
Yes,
correct.
ma'am.
It is
Correct.
DNS server. Fine.
Server.
Okay, so next I'll go. In a dash namespace, each name is made up of several parts, whether it is a flat, or hierarchical, organized, or whatever. In a dash namespace, each name is made up of several parts. Very simple.
Hierarchical.
Yes.
Higher.
Shall I move?
Yes, ma'am.
Yeah. Okay. Probably some questions I have added in the protocol sections also. Yeah. Read the first one. A RIP is based on dash.
Distance. Distance
Shortest
vector routing.
Shortest path routing.
Yes, it is shortest path routing. Please recall your concepts.
Oh.
Please see. I have option as link state routing, shortest path, path vector, distance vector. So your RIP is based on what? Shortest path only. Any doubt in this question? Any doubt in this question?
No, ma'am.
Shall I proceed? Okay.
No, ma'am.
Yeah, BGP is based on dash. BGP.
Path vector.
I think we can select shortest path also because since the option holds good, B as well as C also holds good here. Okay. Yeah.
Oh,
Sixth
okay.
one. OSPF is a dash protocol. Open shortest path first is a dash protocol. He's asking you the options are BGP. Definitely it is not because BGP is a different protocol used by path vector routing. Next, he is asking whether it is an RARP, reverse address resolution protocol will never come into picture here. So option C is also ruled out. D is IGMP. It is a protocol at the internet layer, so we are not making use of that. So OSPF should be dash protocol. It's an interior.
IG.
gateway protocol. Fine. So next,
IGP.
it's IGP, not IGMP. IGMP is different. Okay. So next, we have an area border router can be connected to dash. You remember the area border router? Remember your OSPF? In the OSPF, we have something called as areas. So your entire autonomous systems is divided into something called as areas. So remembering that an area border router can be connected to dash.
Another network.
Only another network or another router or another network?
One or more areas.
Area border router. I'm talking about the border router. Please remember the diagram. It is only option A, that is, it can be connected to only another router. Okay. Sorry, not A. It is another router or another network. Sorry. It is another router. Yeah, B it is. Another router or another network. Okay. Yeah. Go to eighth one. Yeah, eighth one is very simple. I need not have to tell. Eighth one is one-to-all communication is called as dash communication. Very simple.
Broadcast.
Yeah. Shall I move? Yes. In an hierarchical namespace, the tree can have dash levels.
128.
128.
Yes.
120.
Yes, it's correct. Dash domain is used for address to name resolution. Inverse. I think the question is repeated. Yeah. Let me go to the third one.
Inverse.
Yeah. Which of the following label does not belong to generic domain?
IN.
Please read. Which of the following does not belong to generic? .com is for commercial, JO is for government service. Yeah.
IN is here.
IN is the one which does not belong to any generic domain. Okay. Resolver is dash. What is a resolver?
DNS client.
DNS client.
Very good. It's a DNS client. Nowhere it is a server or a primary server or a root server. Fine. So fourth one is DNS client. Fine. Country domain section uses dash character count abbreviation. I think I discussed yesterday.
2 ma'am. 2.
Yeah. You know that it is 2. Yeah. Fine. Next one. Is it informative? You asked me to solve the problems. No problems in this particular chapter. So is it informative?
Yes, ma'am.
Yes ma'am.
Okay, go for the sixth one. Dash server creates, maintains, and updates the zone file. Remember, we have a zone, we have a domain, we have a label. So please recall that. So and tell me, dash server creates, maintains, and updates the zone file. Yes.
All servers.
Secondary.
Think.
Like the root will have too much to update, so it'll either be primary or secondary, I thought.
I think I have still more questions with respect to primary and secondary. Shall we hold back this question so we can answer this later? You are giving your answers wrong.
Okay, ma'am.
Okay, yeah. Please let me know this. A full domain name is a sequence of labels separated by dash. Sorry,
Dot.
I gave the answer. Yeah, it's very
Dots.
simple. It is dots. Yes.
Dots.
Sixth one. Next. A dash server loads all the information from a primary server. Probably now you'll get the answer.
Second.
It is the secondary server. Is this clear? Dash server loads all the information to the primary server. It should be a secondary server only. So your answer for this would be now the root. For the sixth one, the answer would be the root. Okay. Let me go with the next. In the domain name, So please understand this. In the domain name chal.atc.fhda.edu. Dash is the most specific label.
DHA.
Specific label.
CHA. CHA.
Why do we call it as specific? Yeah, answer is correct. Answer is correct.
Ma'am, because
Why it is called as specific? Yeah.
because it is unique for every individual. So
See, the first one, see, we are how are we reading this? We are reading in an inverse tree structure, remember? In the inverse format we are reading. First would be chal dot, next would be chal dot actc dot, next would be chal dot act dot fhda dot, next would be the complete till the edu. So yeah, the first domain is what we call it as the specific label. This is the highest and this is the root. Okay, so this is the most specific label, that is chal, right? Yeah. The root of the DNS tree is dash.
String of 63 characters. An empty string.
Very good. All the other options are like it is giving the answer correctly that B is the right one because all the other three are wrong. Okay, the root DNS tree
Ma'am,
is a
is
string
it
of
not an empty string?
the root of the DNS tree is eighth one, right? The root of the DNS tree is dash is telling. How
It
are
should be
we?
because the root
Oh,
is
sorry.
always signified by an
It's
empty.
an
Yes,
empty
yes.
string.
It's an
63
empty
is the
string.
max characters of a label.
Yeah. Sorry. It is an empty string. Fine. Yeah. Now, yeah, the question is reversed now. When the secondary downloads information from the primary, it is called as dash transfer. Very simple.
Zone.
Yeah, it is zone. So nowhere it is domain
Zone.
label. Yeah, zone is the answer because we are taking the information from the secondary to the primary. Yes. Next one. A dash is a server whose zone consists of the whole tree.
root server.
Root server. Root server.
Yes, the whole tree it is consisting of. So it is a root server. I think, what's the time? I think I have to initiate the other session.
10:27, ma'am.
Yes, ma'am.
Another 3 minutes are there. Okay, we'll wind up with another. Yeah, it's the root. Next one is a pointer query involves the dash domain. Yesterday I discussed PTR. Yesterday I discussed PTR. What is PTR? Pointer record resolver. Why we need this pointer record resolver? Yes, anybody?
No.
Yesterday I discussed when I want anything with respect to an IP address mapping to a domain name, I go with a PTR query. What is that PTR query? It is a pointer. Yeah, it is the pointer record resolver. So it should
it's
be
like
inverse.
address to name.
Inverse.
It is address inverse only. Okay. So remember, a pointer query is nothing but a PTR query. A PTR is nothing but a pointer record resolver. Okay. Why we are using this? To map an IP address to a domain name. When I have an IP address, to get the domain name, I go with an inverse mapping. Fine. Yes. Next one. Each node in a tree has dash, which is a string with a maximum of dash. Read the question properly.
Label 63.
Label
Yeah.
120.
Label and it is 63 with a string of 63. So answer is C, label and 63. Okay. So let me go to the next one. To have an hierarchical namespace, a dash was designed. And the question is vague. Yeah, the domain namespace was designed.
My namespace.
Yeah. Yes. The dash domains define registered host according to their generic behavior. Question is repeated. It is
Generic.
Yeah, generic. In a dash namespace, a name is assigned to an address. A name in this namespace is a sequence of characters without structure.
Flat.
So it is without structure, so it should be flat.
Flat.
Yeah. In the internet, the domain namespace or the trees, I'll not upgrade it. I'll go with the next session. The time is off.
Yes, ma'am.
Yeah, I'll just initiate the next session. This is divided into dash different section. Yes, what is this? Yeah, the complete DNS is divided into how many sections? Hello? Are you people to hear? Are you people able to hear me?
Yes, ma'am. Yes, ma'am.
Yes, give me the answer then.
3.
Yeah, it is 3. Which are those 3? Generic?
Generic, country, and inverse.
Yes,
Generic, country, and
yes.
inverse.
Yes, very good. Shall I proceed?
Yes.
Yeah. In dash resolution, the server returns the IP address of the server that it thinks can resolve the query. Please understand the question. In dash resolution, either it should be iterative or recursive. Fine. So out of the two, the server returns the IP address of the server that it thinks can resolve the query.
Iterative.
Yeah.
Iterative, ma'am.
Yes, it is iterative, not the recursive. Fine. Yeah. In the domain namespace, read the question. In the domain namespace, chal challenge.atc.fhda.edu. Dash is the least specific label.
EDU.
Yes.
EDU.
See, since you are reading from the inverse way, so it should be edu. Okay. The answer is C. Yeah. So let me move on to the next one. Yeah. A host with the domain name pit.arc.nasa.gov. is on the dash level of the DNS hierarchy tree. The root is level 1.
4.
5th, ma'am.
Read properly. Pit is there. .arc.nasa.gov. So either it should be 4th or 5th.
5th.
Yes. Is it 4th or 5th?
5th, ma'am.
Why? Please count 1, 2, 3,
Because
4, including the root. Okay. So it is 5. So answer is C. In dash resolution, the resolver expects the server to supply the final answer.
Recursive.
Yes. So there's no confusion, right? Because it is directly to supply the final answer. You know that it is not iterative. It should be recursive only. 20th answer is recursive. Fine. Okay. So let me go with the next. A dash server loads all information from the disk file. Yesterday I discussed.
Primary.
A primary. A primary server loads all the information from the disk file. Okay. So go with the next one. What is this? Okay, this is related to routing protocol. Which of the following is not the requirement of the routing function? Correctness, robustness, delay time, stability. A common sense question. What should be the answer? Yes, it is the delay time. Allows the administrator to assign a cost called the metric to each router. Forget about the last one. So the answer should be either A, B, or C. The dash protocol allows the administration to assign a cost called the metric to each router. Which protocol? Which protocol? Why you're taking so much of time? Yes, anybody? Yes, are you people there?
Yes, ma'am.
Answer.
RIP protocol, ma'am.
Which protocol?
RIP protocol, ma'am.
No. RIP is using, so let me give you the answer. RIP is using hop count, and OSPF is using cost as the metric. BGP is not based on this hop or the count. BGP is based on the path. So the answer should be OSPF. Got the idea? RIP is hop count, OSPF is cost, and BGP is path. Is it clear?
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Yeah. In OSPF, a dash link is a network with several routers attached to it.
Transient.
Yes, it is transient. No, not multi-point. Read the question. In OSPF, a dash link is a network with several routers attached to it. You remember a mesh topology with each router connected to each other router in the diagram we have discussed previously. So it should be transient. Okay.
Okay, ma'am.
Yeah. In dash routing, the mask, it's common sense question. In dash routing, the mask and the
Default.
destination address, are both 000 in routing table. So
Default.
it is default. No second thought about this question. Is this clear?
Yes, ma'am.
Yeah. The routing information protocol is an intra-domain routing protocol based on dash routing. Simple.
Distance vector.
Yeah, it is distance vector. Don't
Distance
think about. Yeah, it is distance vector routing. Yes. Next, for purpose of routing, the internet is divided into dash. For the purpose of routing, the internet is divided into dash.
Autonomous.
What autonomous? There are networks as well as systems.
Networks.
No, systems, right? The entire internet is divided into something called as an autonomous systems. Once again, the autonomous systems will be divided into something called as an areas. Remember this?
Oh,
So
yes.
it should be autonomous system.
D.
Okay. Yeah. The technique which requires, this is a common sense question, no network information is dash. Please read this.
Random route.
No.
Flooding.
Yes, it is flooding. That does not need any routing information. Just it will flood the packets to all its destination. Am I right? So it should be flooding.
Then random route.
Random routing is not a part of any of the routing protocol.
Oh, okay.
Okay. Yeah. What is an area? You know this. What is an area?
Part of autonomous system.
Yes, very good. It is a part of autonomous system. Your previous question was the answer. Like the previous question was the answer. Yes. In OSPF, a dash link in a network with in OSPF, a dash link is a network with several routers attached to it. Yeah, once again, the answer should be, it's repeated.
Transient.
Yeah. Yes, it is transient. Yes. In the BGP, the criteria of the policy is set by the dash. You remember attributes, the broader gateway protocol attributes. The attributes should be general as well as internal. So according to that, the answer is, I think you will not give the answer. It is not the system, not the user, not the medium, it is the administrator. So the administrator decides the policy criteria in the BGP. Okay. Yeah. In periodic update, a node sends its routing table normally after every dash.
30 seconds.
Yes, it is 30 seconds. Next, the routing information protocol cannot have more than 15 hops if infinity is
14.
No.
16.
Is
16.
16. Yes. I think I completed. Yes. So let me end this. Okay. Was it informative?
Yes, ma'am.
Okay, I'll share the slide. Don't worry. So let me enter into the next topic of my interest. That is, yeah. Please wait. I need to go with. I'll share all these things. Don't worry. Yeah, my next topic is ATM networks. Yes, are you able to see the screen? At least I'll just introduce and leave it to you with the concept of ATM. Are you able to see?
Yes, ma'am.
Yes, ma'am.
Shall I proceed with the ATM network? So the next topic,
Yes,
I told
ma'am.
you, we don't have any connectivity for each and every topic, whatever I'm discussing. So now I need to proceed with a new topic, that is the asynchronous transfer mode, or what we call it as the ATM networks. Now let me give you a brief idea about the ATM network. Before I enter into the ATM network, let me tell you a story where I can say this now. With the recent technology, the ATM network is already obsolete. Okay. Now you can ask me a question, why it is a part of a syllabus for us, ma'am? So probably earlier your seniors had this as a elective subject itself. See, we have so many subjects attached with the computer networks. Like one was your ATM networks, one was your ISDN, integrated service digital network. One is the multimedia communication, which you have as an elective in the next particular semester. Next we have CCN itself, right? So these are all the subjects attached, interrelated to each other. But as a part of your syllabus criteria, this particular topic was removed because the entire network is already obsolete. So what the idea here is, in computer networks, what they are asking you is to know at least what is the basic concept of an asynchronous transfer mode type of a network. It is not all time money, so it is an asynchronous transfer mode type of a network. So since it is an obsolete thing, so he has not kept it as a complete part of a syllabus. So I'll introduce to what is an ATM network and the topic what he is asking you to study related to the ATM network. Only such concepts I would like to highlight. Now, if I go back, if you just remember, I think in your second unit, we have come across frame relay as well as X.25 protocol. I think most of you remember this frame relay and X.25 protocol. Do you remember? Is anyone acknowledge?
Yes, ma'am.
Yeah. So this frame relay, this X.25 protocol, and your ATM networks are nothing but, I can say, the sister concern networks. Right. So when I mean sister concern networks, now if I go into the introductory concept of an ATM, I can call this as a switching technique. This ATM itself is nothing but a switching technique used by the telecommunication networks. Now, yeah, ATM stands for asynchronous transfer mode. And I told you that all these X.25 frame relay as well as ATM network are sister concern network. That means if I talk about something called as a frame relay, ATM or your X.25, all these networks are at the lower three layers of your OSI model. When I mean the lower three layers, your physical, your data link layer, as well as your network layer comes into consideration with all these three types of a network. That is, we have something called as the concept of broadband integration as well as narrowband integration. So this concept of broadband as well as the narrowed band to provide a switching between an end-to-end systems was enabled by this frame relay X.25 as well as ATM networks. Now, why ATM dominated when compared to your frame relay and X.25 was, See, earlier we had different types of network for different types of data. Now, for example, if I take a telephone network, so for the telephone network only, I have something called as a PSTN type of a network. You are aware of this. Similarly, for your wireless, you know that I have already a GSM networks. Now, for your data, you know that I have a local area network. In the local area network, I can have a fast Ethernet. I can go with the gigabit Ethernet. I can go with a token ring topology type of a network, etc., etc. See, name any concept. You have one different network for each. Like for voice, you have a PBX or PSTN. For data, we have LAN. For WAN, we have X.25 frame relay or your TCP/IP model. And for your video distribution, we have something called as cable networks. For your wireless, we have something called as cellular networks or GSM. So what did I mean by all these things is, for each particular application, we are having different types of networks. But what is our aim? What was our aim was to bring all this into a common platform. So that is what is enabled by an ATM, right? So basically any type of data we can transmit, either it is your voice, your audio, your video, your text, or any multimedia data information can be combined and transmitted in this particular type of a network, what we call it as a ATM network. Got an idea now? So instead of having these different types of distributed networks, I can bring it to a common platform. One network only can do this job, and which was that network which can do this job, though it is obsolete. In my discussion, though it is obsolete, in the recent trend, it is not used. Probably why it is not used is based on the capability of its speed and the data rate what it can withstand. So the data rate restricted to our ATM is just 64 kbps. When we have this TCP/IP model which is dominating your entire internet, I think we will not go with an end-to-end connectivity using this type of an ATM network. But still, it is a part of our discussion. Though it is an obsolete, still it is a part of discussion. So let me enter into the concept of why we need this particular ATM networks. Yeah. Okay. Basically, just now I gave you an introduction, and this was the motivation for the ATM network. That is, bringing everything into a single platform was the idea. So, a single platform that provides end-to-end connectivity was the first motivation for an ATM network, and a universal platform that integrates different network services was also one of the idea. And this ATM stands for asynchronous transfer mode, or you can also call it as cell switching or a cell relay protocol. Designed by the ITUT standard. Okay, so who developed this particular standard is International Telecommunication Union for Telegraphy and Telephony was the standard to evolve this ATM network. And this is also referred to as a seamless network. Please mute your. Please, all of you, mute your thing. I'm having disturbance. Okay. So these were the idea behind your motivation of the ATM network, and we also call this network as a seamless network, seamless connectivity, that is end-to-end connectivity within a single platform. Anything you can transfer, your voice, audio, video, text, anything which is having an end-to-end connectivity without any break is a seamless network. So ATM is also referred to as a seamless network, right? So with this idea, let me go into the definition, and the standard which defines your your ATM is under ITUT I.113 standard. Probably this could be a quiz question. Please remember, this standard defines your ATM network. Fine. So one more thing is, it is a transfer mode in which, very important, this is a transfer mode in which the information is organized into something called as a cells. So here, ATM network is a fixed type of a network, fixed cell type of a network. See, we have a packet, right? So the packet can be variable in our TCP/IP model depending on whether I go with an internet version protocol 4 or version 6, right? Whereas in case of our ATM network, so this ATM network is a fixed sized network, right? What is that number? Later I'll come. So this is a transfer mode in which the information is organized into cell. Now, why do I call it as asynchronous? So asynchronous here refers to the occurrence of the cells containing information is not periodic. So when I'm at the physical layer, I'll be discussing about the concept of why we call it as asynchronous. The name itself is telling you it is an asynchronous transfer mode. The entire idea of asynchronous is however you send the information, it is not periodic in nature. So basically it uses time division multiplexing only, but it uses an asynchronous time division multiplexing. That is the concept, right? So now the basic terms which defines these ATM network is, one is a transfer mode. Just now I spoke, it is a fixed cell. Fixed cell. What is that size of the fixed cell is the discussion. Then it is a cell based structure, and it is an asynchronous transmission, whatever we are having. So these three important criteria forms the basic definition of your ATM. So let me go into this concept of why we call it as asynchronous transfer, and why it is called as ATM, that is why it is asynchronous basically in nature. Now basically it is a multiplexing scenario, whatever we are having here. Very well, you know, how many input lines are there? 3 input lines are there, right? And each one has its own packets. I'm not bothered about right now whether it is a fixed or variable packet. I'm just identifying you how we are doing ATM multiplexing using an asynchronous time division concept. Now you can see here I have 3 packets at the user 1, 2 packets at the user 2, and 3 packets at the user 3. Now at the tick of the first clock pulse, what will happen? A1, this probably, if I name it, and C1 was supposed to be transmitted in case of a normal TDM structure. But what it is happening at the tick of the first clock pulse, it is not transmitting this one. What it is transmitting, A1 as well as C1. Can you make it here? So A1 as well as C1. So it is asynchronous in nature, and it is not wasting the bandwidth. So this is why your ATM is so peculiar with the technology. So how is the transmission done? A1 C1. Next it should be A2 B1 C2. Next it should be at the tick of the clock pulse 3, it should be A3 B2 as well as C3. So I can justify this statement that it satisfies the condition of asynchronous transfer, right? Now when I call it as a cell based structure, then I have to come for this particular concept. Yeah, when I come to the transfer mode or the cell-based structure, basically your ATM works between both the circuit switching as well as packet switching. So you know the difference between your circuit switching as well as packet switching. Circuit switching is nothing but which have a dedicated communication path. A packet switching is nothing but what is placed in this packet switching is based on a virtual connection. So this ATM is utilizing both the connection oriented as well as the virtual concept. So hence this ATM is also referred to as fast packet switching technology. And now since I told you it is a cell based structure, now what should be the size of this particular cell? So by default they have fixed the size of the cell in an ATM network to be 53 bytes. Now out of this 53 bytes, just concentrate on this particular just concentrate on this particular diagram. Out of this 53 bytes, 5 bytes are reserved for header, and the remaining 48 bytes are reserved for payload. So now only in this particular type of a network we have such type of arrangement wherein which the cells are fixed sized cells. So please remember, an ATM cell is one which have 5 bytes of header plus 48 bytes of data. Totally it is a 53 bytes of data. Now you can ask me a question, why it is specifically reserved to be 53 bytes. Now it is just a compromise. Why just a compromise is, if I go with the cell size of 32 bytes or 62 or 64 bytes, 64 bytes has better transmission and efficiency, whereas 32 bytes have small delay. So either of the one, see, both are having its own advantages, right? So some wanted it to be 32, some wanted it to be 64. So they made a compromise that when this technology was coming to evolution, so they made a compromise and they came up with a 48 byte structure. Got an idea? So both is giving some advantage. Why not we go with this structure, that is 48 byte, which has 5 bytes of header as well as 48 bytes of payload. Right? So second concept is also clear. What is that? According to my definition, first one was clear, why it is asynchronous. though it is following TDM only, but still it is, the transfer is, occurrence of the cell is not periodic, so it is asynchronous transfer. And transfer mode and why it is cell based, I give you a clarity, right? So with this introduction, let me give you an idea of how we can, why it is a cell based transfer. You can see I have an ATM multiplexer in which all the data which is entering into this multiplexer should be of fixed size, whether it is your voice call, whether it is a data, whether it is a video, anything it could be. It should be a cell of 48 bytes of payload. The other 5 bytes are exclusively reserved for the header. Later I'll come for what is this VCI as well as VPI. Now you got an idea. Basically an ATM is an asynchronous transfer. Why it is asynchronous? Occurrence of the cells are not periodic in nature. And why it is cell based? We have a fixed sized format, so it is called as cell based structure, and hence the transfer mode is also fixed. So these are some of the definition which holds good with respect to the ATM, right? So if you just see here, some more points I have made it clear. So just an idea of all the 3 being multiplexed in your digital pipes. So you can see all the cell size are fixed size cells, right? Okay. Yeah, let me go into the very important factor. Yeah, these could be some of the basic principles of ATM. What are those? Fixed and small sized packet. Why small sized packet? Some or the other we can avoid congestion, we can avoid contention in a network. So we go with the fixed as well as small size packet, connection oriented, as well as packet switching, which uses virtual channels and virtual paths. And we have a negligible error and flow control mechanism. Since the cell size are fixed cell size, we can increase the quality of service to some extent, right? So let us go with the how exactly the architecture of an ATM would look like. Later I'll come with the structure of your cell. How many minutes more I have? Yes, are you people there? Some are entering, some are leaving.
Ma'am,
What's the time? How many minutes more I have?
it's 11 now, ma'am.
I think I'll extend this by another
Yes, ma'am.
10 minutes. No, I think much of theoretical. I'll stop here. Got an idea of
Yes.
introduction to your ATM. That's it. Long topics are there to enter into. Later I'll come for all these things. I'll stop at this point. So from where I'll fetch is from the architecture of the ATM. Still I have not come with why it is 50. No, I have not told you what are there in the 53 bytes. Out of 53 bytes, 5 bytes exclusively why we are reserving. All those information I'll share in my next class. Is it fine for today? Shall I end the session?
Okay, ma'am.
Okay, many are living. Why? What is happening? See, you don't have much information in your textbooks related to ATM. Probably there will be a 5 to 10 marks question on ATM. So please concentrate, at least 5 to 10 marks. So if I complete your ATM networks, I'll enter into the next topic. That is probably tomorrow I'll complete your ATM networks. One more topic is data compression. After data compression, I'll enter into network security and cryptography. So if I do all these 3 discussions, your 5th unit would be over. Okay, shall I end the session?
Yes, ma'am.
Yeah.